Hello everyone, my name is Zhao Qizhang and here's my student ID card. Today I'm going to talk about my final experiment about understanding the solar system. Let's move on to the first question. What are the Kepler's law and define them? So the first law is each planet moves in an elliptical orbit with the Sun at one of the two foci. And the second law is a line joining a planet and the sun sweeps out equal areas in equal intervals of time. And the third law is the square of planet's orbital period is proportional to the cube of the semi-major axis of its orbit. Let's move on to question 9a. And my answer is yes. The planet moves slightly as the moon orbits around it. And question 9b. The figure from question 1 shows the center of mass lays very close to the center of the star in this scenario. Due to the star's significantly greater mass, the star appears almost stationary, while the planet orbits it, which means the barycenter is inside or near the center of the star, not between them. And the figure from question 4 is the center of mass shifts slightly away from the center of the sun, but remains very close to it, because the sun mass is still significantly larger than the planet's. And the last one shows the center of mass now lies very closer to the planet, and may even be outside the star entirely, somewhere between the star and the planet, but noticeably biased toward the planet. So question 9c, my answer is, in sun-planet systems, the barycenter is usually deep inside the star due to its massive size, while in planet-moon system, the barycenter lays within the planet but noticeably off-center, sometimes close to or beneath its surface. So question 11a. From this figure, we can know the simulation shows the distance between the Sun and the Earth as approximately 1 AU. Because 1 AU equals to 2 grid squares, each grid square equals to 0.5 AU. Therefore, each grid marking represents 0.5 AU. And question 14a. The left-hand side is my experiment result, and the right-hand side is each planet distance result. And I put all figures there. So according to these figures, my answer is yes, the data supports Kepler's third law. This consistency across multiple orbits confirms that as a planet's distance from the Sun increases, its orbit period increases in a predictable mathematical pattern, in line with Kepler's finding. Question 15a is Mercury, and its speed is nearly 47.9 kilometers per second. And question B is Neptune, and its speed is nearly 5.4 kilometers per second. And the reason for this is planets close to the sun move faster because the gravitational force is stronger, so they need a higher speed to stay in orbit. And according to the Newton's law, this means the smaller distance, the higher speed is, and the greater distance, the lower speed is. It also matches Kepler's third law, which shows the planets further from the sun move more slowly and take long to orbit. From this experiment, I used a simulation to explore how gravity affects orbit based on Kepler's law. I learned the planets move in ellipses, not circles, that Kepler's first law. Further planets move slower and take longer to orbit, proving the Kepler's third law. And closer planets move faster, which confirms the second law. I also saw how changing mass shifts the center of mass. Overall, the simulation helped me understand how gravity, mass, and distance affect planetary motion. And here's my reference. That's all. Thanks for listening.